Good afternoon, friends. Good afternoon, friends. We are just going to have a revision of the problem which we solved a little earlier. I was not very happy with what was seen on the blackboard, and hence I just thought I'll have a redo of it. But of course, this is based on the class which we had just now. As I was telling you, we in the previous lecture we were looking at the parts of a building. And that was a really good experience which I had with you. You were very proactive in whatever you did. Now, we had told that we'll go for the RC portion of what you see or what is not really seen much in a building. And that the survey of the quantities of those things will be done at this stage. Again, as in the previous case, we will go through the parts of the building and then go ahead. And as we were talking about the hostel building, we didn't have the corridor included in the previous occasion, but this time we'll go in for the corridor also, and I hope you find this useful. So, the first thing that we do is we first get the previous building. Now, I'm not going in for the sizes exactly as what we had in the last class. I might have a little variation. So let's take it that the room is 3.5 meters, and beyond it we have the corridor. Okay, so let the corridor be 1.5 meters. Okay, so this should be about 1.5 meters. So here this portion is the corridor, and that is the room. So we had a brick wall here. Of course, it was 115. So because of that, we are not actually going to go and give a beam below that wall. However, we are just indicating it in this drawing so that we get to understand why this 5 meter which I am wanting to have is coming into the picture. So here this will be 3.5 meters. Of course, in any drawing we are supposed to be going ahead and keeping the dimensions in millimeters, but for convenience sake I am keeping it in meters here. So, and I guess this was around 2.5 meters. So I am keeping this at 2.5 meters spacing. Here we are going to have a column. Mostly the columns are inner flush. The beams are also tried to be kept as inner flush. It means that when you are looking at a beam and a wall, they will be in the same vertical line. So this is what we mean by saying that it is inner flush. Now, it means that the column will project into the building by what is the thickness of the wall. So I am just getting the column in place. Now, please note that I have kept a projection beyond the wall or beyond the outermost wall or the center line of the wall over there. The reason this is done is only when you do it in this fashion, you are going to have a flush appearance. Okay. So again, this will be half of the brick thickness, making this 125 mm, and this half will be 125 mm. Same thing goes to all the columns, including the one in the outer face. Now, we are told that the wall between the bathroom and the living area is 125 mm thick, for the reason that this is going to have water on one side and the other side is dry. So to prevent moisture movement, we keep all such walls as 250, and we require to give a beam under such walls because the load is quite heavy. So this beam should run along this center line, and I presume this is 1. Okay, let it be 1.25 meters. 1.25 meters is a really good size, And as we had mentioned earlier, it can be like a concealed beam also, which has been kept where the slab is just folded and kept. That works very well in all the cases, and it doubles as a beam as far as we are concerned. Okay, so that is the sunken, that is about the sunken slab portion. Coming back here, so now we've got the basic skeletal framework in place. We will now go ahead and build the flesh or over the skeleton. In this case, we are going to do the beams and other things. But before we start doing that, let us keep the grid lines. The grid lines are very important. So, I am calling this grid A and this as grid B. Here we have, let's see. So, we got 3 grids for our building, and once we got this, we can do the beams. So, of course, this beam has been drawn. We are going to keep this beam as, or this will be 250 mm deep, and since the span is rather small and load may not be to that level, we will keep this as a 500 mm deep beam. So, that beam is 500 by 250 mm, and this beam is quite long. However, it is only supporting the 125 mm thick wall. Besides, of course, we got the flow loads also acting on it. So, it will not be to that extent. Still, I am going to keep this as 750 by 250 mm. Okay, and this beam is again a cross beam, and this will be this can, as we were telling, that this can double up because of that sunken slab portion. So, if I were going to do that, this will be the regular floor beam, and below this regular floor beam is going to go and make the sunken portion, right? So, this is typically between 600 to 900 mm deep. In this case, I am keeping it as 750 mm. Okay, so this indirectly translates that this beam is going to be 750 mm deep, and from the consideration that we need to have the toilet waste pipe going out, we can either give a sleeve in the beam or we can put a beam at a lower depth. In this case, for the sake of simplicity, I am just making the assumption that we are providing a sleeve through which all the waste pipes can go. So, it indirectly means that this beam is going to be 750 plus 125 mm thick. Okay, so otherwise we can even make it as 600, which is the minimum depth to which we can have. So, I am just making this as 600 mm, and so this makes it 725 mm deep. Okay. So, now we have got all the beams sizes in place. So, again, this beam I am going to keep it as 500 by 250 mm deep. So, all the beams are in place. These are the principal RC elements. Then we go for the column. The column we will keep it as 450 by 250 on the other direction. This gives us a good idea as to how the beam and column layout is. So, this is going to be the beam at first floor, or beam at level I can give, if not the level, beam over ground floor, or I can also call it as typical floor beam layout, because this is going to be just repeated across any number of floors. Now, if you remember, we told that in the ground floor we are going to have beam to support the wall in the toilet area, in essence along grid B, and that is going to rest on stub columns. So here for this, we don't really require a beam which is as deep as the others, but anyway we'll keep it at the same 500 by 250 for convenience sake. In fact, 500 by 250 should be the correct size because we got quite a high wall if I am going to consider these two beams. So instead of making an ambiguity, I am going to keep this as 650 by 250 plinth beam. There is going to be a plinth beam which is 650 mm deep and 250 mm wide. And right. So if suppose I am going to let me just erase this portion. We will generate the plinth beam layout, in particular along grid B. So if I am going to take a section like this and call it 1, 1, it's going to be extended throughout, and this is how it's going to look. Along the same line of thought, let us call this as grid 1 and this as grid 2. Of course, when you are having a very continuous system, this 1 and 2 tend to lose meaning a little, but still let it be so. Now, what happens here, when I am taking a section along BB, you are going to have a plinth beam there and footings. Now, these stub columns can be just 250 mm by 250 mm because they will not be carrying much of moment because they are balancing each other. So on top of this we have the brick wall. So we can, I'm just going to keep this foundation pad as 750 by 750. It's a square footing and this will be 250 mm deep. So this takes care of the stub columns. We will now go ahead and generate the elevation, the cross section, because we need to understand what are the other elements which are coming. So for that, so this will be the plinth beam layout along grid BB. Along grid BB. Now, I will start from the top. We will make the following assumptions that founding level is typically you give it from the natural ground level, but in this case, for the sake of simplicity, I am taking it as from the finished ground level. Of course, this is a thing which I hope you don't continue on. Always the founding depth is fixed from the natural ground level, because at the time of the excavation or the survey which is being done, the excavation pit which is being used, or the for bearing capacity, what is the technique they are using, it is all from the natural ground level, not from the finished ground level. Finished ground level typically is higher than the natural ground level, and you will be expected to at least go 1 meter below the natural ground level before you make a footing. So here I am going to take it as founding level is 2 meter from the FGL. Okay, so founding level is 2 meter from the finished ground level, and we are going to keep the finished floor level higher than the finished ground level. Here we will take it that the finished ground level is say around 450 mm or let's keep 125 steps, 250, 375 mm above the finished ground level. So FFL or finished floor level is 375 mm above FGL, finished ground level. So we've got all the levels which we require. So I'm going from the top. We don't have to worry about the parapet here because I'm only doing the roof slab. So let us, for the sake of convenience again, take it that this is only a ground floor structure which is only having ground floor. So in which case, if suppose it's something having more number of floors, there is no sweat. In fact, it's easier. You just need to get the levels or the quantities above the finished ground level. Finished floor level. So this will be a repeating unit to the number of stories which you have. Of course, provided you are having a repeated unit. In certain cases, for instance, some hotels, we've got banquet halls which are having a large column free space in the lower floors. They'll have a transfer girder, and above that you'll have the totally different column layout and even beam layout. So in those cases you'll have to do a case to case study of the plans and then work out the quantities. But typically when you're taking a residential apartment building, you are going to have a repeating unit. So the moment you take the quantity from the finished floor level till the slab above it, then you will find that you can just multiply the quantities and get it, and there's not going to be much difference. Of course, you may have to book the quantities a little differently, but that we'll see in another lecture. The quantity is not going to change, but the specification and the specification to which the quantity is being made will vary. Okay. Now, coming here, you are having a slab above the ground floor, then you got a beam, and this beam, okay, now I'll again say that this is a view along 2-2. This is view along 2-2 or section along 2-2, and it's not actually this long. This section is only till this point that I'm doing. So I'm just viewing the cut section. If I have to be very precise, that has to be put here, but I'm not doing it so that because of it will be crowding the drawing over there. Now, after you do this, we can fix the height from the finished ground level as 3.5 meters. Okay. So now this will become the finished floor level, FFL. Typically FFL is given the 0.00 meter elevation in a building. So you would, from my explanation, the explanation which I gave you a little while ago, you will be able to understand the reason why we are going to keep 0 at finished floor level. And after this, we've got the finished ground level. Typically you will have some steps seen, provided of course this is somewhere along the main road, main door. So you got a corridor here, so somewhere along this corridor definitely there is going to be the main door, and you will be showing the steps, and 125 into 3 you are going to reach your finished floor level. Here this is a made up soil, and now we are saying that the founding depth is 2 meter from finished ground level. So I am going to say that there is going to be this sand filling etc. what we spoke about, mud mat and a PCC layer, and above this only we are going to have a foundation, and this is going to be a much bigger foundation than what we had. It was 750 by 750, and in this case I am just going to keep it as a 2 by 1.5 meters footing. Okay, 2 by 1.5 meters footing. So here the column goes right up to the top. This will be the cross section which we have. Now here we have a door or anything. So here this has to be 2.1 meters, and if suppose your design depth of column is 500, if your design depth of column is 500, your column your beam, typically the depth is 500 from this point. Okay. Now this will be the beam which is perpendicular to this face. I am marking it as X, and in the other direction the beam is 750 by 250. So that beam is seen as a line. So this is 750. This value is 125 mm thick because that's the thickness of slab. If you are going to be very particular, if suppose you will have the DPC on top. Of course, in the previous class you would have considered the DPC, so I am not repeating the quantities. One thing which we should never do is have a repeat of the quantities which have been worked out. Okay. So now when you look at this, you will find that all the things have been taken into account. Probably the plinth beam, the lintel beam. So lintel can be 350 deep. So above this, from here to here, you have 1.4 meters. There's a 1.4 meters gap over there. So that makes it as 3.5, and 500 minus 125, 375. This will be 375 mm D thick over here, and this is 1.4. Then we have a 350 or even 400. Let's keep it as 400 mm deep beam. Again, that will make calculation a little easier. So this is 0.4 meters, and this is 1 meter. 1 minus this one, this will be 675 mm of brickwork above the lintel. So of course here, since we are not worrying about the brickwork and it's only the RCC, I am not showing any of the hatches which will indicate that there is a brickwork. And yes, floor slab in this case is nothing but a slab on grade. It won't have any structural contact with the rest of the RC elements which we have. You can just make it, if you require, you can make it on the brickwork, but there will not be any continuity with the main column. And one more element which we should have marked is the plinth beam. So here let's work out the quantities again. Now this I am taking a totally mud mat, PCC, everything put together is 275 mm thick, and we have told that, and this is what we consider as founding depth. This is the place where we where at least I will call that foundation is being kept. This is 2 meters. Now from this 2 meters, 275 has gone, and we can take this foundation to be 425 mm deep. Now this is again a matter of convenience. So 5, 6, 7, 700 mm goes, and we have 1300. 1300 from finished floor level. Now this plinth beam, we can keep it at least 600 mm below the finished ground level, so that people don't accidentally dig out soil and erode the filling which we have below the finished floor level. Okay, so now if that is going to be 600 mm, and we have not mentioned the thickness of this beam. This beam we will take it. This beam will not be very deep. This need not be deep because it's only going to take. Oh yes, it's going right up to the top. So here let me take this at 750 mm. 750 is it required? No, 500 should be enough. So I'm just keeping it as 550 mm deep by 250 wide. So this makes this beam 550. So 600 plus 550, 1.1. It is almost going till the foundation. Okay, but I'm not changing the values. So if you had a foundation which is at a 2.5 meters depth or 3 meters depth, you would have found that whatever values which you got would have kept the plinth beam sufficiently depressed and sufficiently depressed from the finished ground level and sufficiently high above the top of the footing pad. And I'm not changing the values which have been given now, and this is reasonable. Just that founding depth probably I should have kept it at 2.5 meters. Okay, so 2.5 or 3 meters, and I'm going to have the same 550 over here. So this is 550. Here you will have only 150 mm above. Okay, so this more or less covers the details which we require. And if suppose you are going to take a section over here, a section like this, I'll call this as section 3.3. When you take a section 3.3 like this, what are the things you'll see? It's very narrow, but anyway. So when you take section 3.3, you have your column, that runs through. Okay, then you will have the sunken beam, and again, see in this case what is, of course here the column goes. Here what actually happens, instead of the beam being loaded at the top, it's just going to have the load at the bottom. Probably it's a detailing arrangement, but as a quantity survey we are not worried about the way it's done, the reinforcement which is being done. We are going to get the drawing, we are going to get the design, we are only going to take the stuff from this and put it, and with the experience which we get as quantity surveys, we'll be able to make out if suppose there's any mistake in any of these things, because we would have seen so many drawings, we would have seen so many different structures, and we'll not automatically get suspicious when we see something abnormally different. There can be slight changes, okay, instead of 12 mm rod, 16 mm rod being there, or some other jadoo. However, if suppose something is alarmingly different, you will definitely be in a position to point it out to your design team. So this is the drawing for which we are going to take the quantities.